All right, so here is an OpenShift Container Platform dashboard. We have Portworx already installed and a storage cluster already initialized. Here you can see the storage spec showing that security is enabled, and there is a bunch of configuration already configured, such as manage guest. If you need more information about how to configure and enable security, you can head over to our docs, which show how to enable it via the operator and customize it to your type of environment and needs, such as managing the guest role or increasing the token lifetime. Now let's head over to our cluster and log into our Portworx pod. Here you can see the managed guest role that we have set up for this cluster, which really just takes away the create APIs for guests, as we don't want our guests creating resources like PVs and PVCs and have access to other things such as read only or view capabilities for these types of things. Now, here we can look at the different contexts available within our Pixie Cuddle utility here. There's a user, a view user, an admin user, and some other users above. Now, these users are created through some sort of OIDC, or in this case, we have these configuration files which dictate sort of what roles and groups they are part of. So that's how they're outlined within a PX Secure enabled cluster, often coming from another type of configuration. In this case, we're just lining them up manually. As an admin, I can see all my volumes like you can see here, but if we set our context to our view user and try to do pretty much anything, such as creating a volume, you will not have access to do this. Now, this is what it looks like for PX Secure to work on sort of a CLI level, but as we know, we're really using it through Kubernetes the most, meaning that users will interact with kubectl, and this will need to be able to understand PX Secure as well. Now, if you're curious about how tokens are created, usually admins will do this or some sort of automated system. You can create this through the CLI like auth token generate, also available on the API, and you'd then create the context for that user by passing in the token. However, if you were to use this in a Kubernetes context, that token would need to live in Kubernetes and the admin would need to place it in Kubernetes. So let's see what happens if you create a PVC which doesn't keep any of this in mind. Now, this PVC looks normal, doesn't look malicious or anything, but it doesn't have anything special associated with authentication. So if we create that PVC, head over to our dashboard and to our default project, we can see it's pending, and we're going to go look at why. Permission denied, access denied without an authentication token. So by default, we chose a guest account to be managed, and we managed that guest account to not be able to create resources such as PVCs. So in this case, a guest or unauthenticated user cannot create a PVC. And this is how PX Secure will respond. Now, in order for users to actually create PVCs, they need to be authenticated. So here's a secure storage class. This is using encryption, replication, and passes in a user token in a shared namespace. In this case, the admin placed it in kube system. Now, we'll cover multi-tenancy and how multiple namespaces can access their own tokens, but in this case, a single cluster has an admin created token so that they can reference it in storage classes available to them. So now that storage class is used by PVC002, and as you can see, the PVC gets created no problem, and a volume gets created behind that PVC because it allowed a token to be passed along with its request. So now we're going to head over to our CLI and use the Pixie utility to show that it in fact is created and detached because it's just a PVC. It's not attached to any pods. Next, we will go back into our Portworx pod and look at multi-tenancy. So here's an analytics definition and a DBOps definition. Both are system.users and part of the users group. Now, these get applied to their own tokens, meaning that analytics has their own token and DBOps has their own token. So when we log into OpenShift as a DBOps user, we have access to our own namespaces. In this case, DBOps user has access to the DBOps namespace and can only create volumes based on storage classes that use a authenticated token that's meant for the DBOps team, not any other team. So as you can see, we have a number of DB2 instances running here, and we will initiate a database in just a second. But as you can see, we have our own PX user token within our own namespace, not any shared namespace. And we're going to use this to create volumes. Now, it's a good idea for your admins to limit access to get and retrieve secrets so they can't see other users' tokens. But as you can see here, our storage classes have the DBOps namespace as well as the PX user token secret name. This means that it uses the specific token from DBOps. And in this case, we can go into one of our DB2 databases, look at the volume that is being used for blue data 0. It's using that storage class that has the token enabled in it. And let's grab the name of that persistent volume claim. Now, one way to look at the ownership of a volume is to use the PXE utilities or command lines. In this case, we can run the PXE cuddle volume access show and the name of that volume. And here we can see that that volume ID is owned by DBOps. This shows that Portworx is actually keeping ownership information. Now, if I were to try to manipulate this volume using another token, say the analytics token, and I do an inspect or possibly a delete, I should see access denied to this volume. That volume ID is the same one from above that we inspected, owned by DBOps. So we can't delete it, we can't inspect it as another tenant in the namespaces or Kubernetes cluster. So this allows a separation of access control from the Kubernetes role-based access control layer, as well as the Portworx role-based access control layer. So now let's look at an example of encryption, another added benefit of PX Secure. So this uses the PX Secure REPL 3 storage class, and this will create a Postgres data volume, a secret config map, and deployment of Postgres itself. Postgres will create a volume as well as the deployment and come up in just a second. So here we have Postgres running. If we head back to our pods in the namespace, we can see that Postgres here is in fact running, and the data is mounted at var_lib Postgres equal data. This volume is using that secure REPL 3 storage class, so we should have an encrypted volume. One way to look at whether it's using an encrypted volume is by checking out the volume information, and there's a couple ways to do this. One way is through PXE Cuddle. If you have access to this tool, you can log in as an admin and view the volume with the inspect utility here. And here you can see the attributes should be set to encrypted, and the device path is also dev mapper PXE ENC, standing for encrypted, because it does use dmcrypt for encryption at the Linux layer. So that will show up as the correct volume path name. The other way you can do this is by logging into the Postgres pod and issuing a df-h, seeing that same device path mounted to PostgreSQL/data. So we know this Postgres instance is using an encrypted Portworx volume. Now, one thing to keep in mind is that with all this security and access control, you want to be able to audit your system. So Portworx actually ships with a couple of different audit files. You can find them on each Portworx worker node or Portworx deployed node in your Kubernetes cluster. We can use the ocdebug command to log into our node and view these files. The files are located at varlib osd log security, and there's an audit and access log. Here's a quick sample of what it looks like. Now, you'll have to capture this information if you want to do anything more useful, such as dashboarding. One way you could do this is by deploying FileBeat. This FileBeat container/daemon set within the Kubernetes cluster uses a FileBeat configuration and an Elasticsearch database to capture the data and upload it. Here you can see FileBeat captures the audit and access logs and ships them off to Elasticsearch with a little bit of processing done at the FileBeat layer before applying a target prefix of px audit. Now, when you dashboard this index, you get a whole bunch of information from these audit logs, such as which requests failed, which are denied, which go through, which get permissions denied. And so this is all pretty useful information for auditing your PX Secure enabled cluster. So let's go ahead and create some audit messages that we want to capture. So let's create this user trying to delete a volume it doesn't have access to. You can see it's getting access denied here. We can use a fake token, such as maybe a bad actor would do, create a token that doesn't make any sense and try to fool the system. That will also happen. And then a access denied indicator through a issuer, a fake issuer. Now, when you issue these, the audit logs should capture most of these, and you can see them pop up in our graph here on the bottom right. The top right shows the individual logs that you can get from the logs themselves on the worker nodes, such as the access denied to volumes when they're trying to be deleted, or permissions denied by a specific user when they're trying to do something they are not allowed to do. So keep in mind both the audit capabilities, the encryption capabilities, as well as the role-based access control that PX Secure can deliver for your OpenShift clusters. Till next time, take care.